Random people, there's a 50% chance that two of them have the same birthday. I can work the math out for you someday if you want. Okay. Exactly. Then that's probably what you guys are thinking about. Okay, so here we go. I'm gonna pull you back in here. Okay. So 4.3. Okay. In interest of some homework time, I'm just gonna go ahead. Actually, no, I've been told that I can just. You guys told me yesterday I can just go right to the bell now, can't I? Isn't that what you're used to? Okay, this is great. Anyway, now here we go. Okay, increasing and decreasing functions. Okay, this I think should be fairly straightforward. Okay, honestly, it says when x sub 1 is when the result plugging in x sub 1 is less than the result plugging in x sub 2. When x sub 1 is smaller, then it is increasing. So here's what this is saying. I know it kind of looks a little, but when I put in a smaller number, I get a smaller result. When I put in a bigger number, I get a bigger result. That's increasing. Okay? But conversely, if I put in a smaller number and get a bigger result, and when I put in a bigger number, I get a smaller result, okay, then it's decreasing. Okay? But here's what we're really looking at. First derivative test for monotonic functions. Well, first of all, what the heck's a monotonic function? A function that is increasing or decreasing is called monotonic. Okay? Don't worry about that term. I'm never going to ask you that term. Okay? Monotonic means it says a function that is increasing or decreasing on an interval is called monotonic on that interval. Okay? So this right here, this whole interval, it's not monotonic. That part's monotonic. That part's monotonic. And I'll be honest with you, before this text, I've never heard that term. So don't worry about it. Okay? Okay, so here we go. It says, if f prime of x is greater than 0 at each point x that is an element of or belongs in AB, then f is increasing. If f prime of x is greater than 0, it's increasing. Before I explain, do you guys agree with that? Does that make sense? Why? Because it's a positive slope. Good. When the slope is positive, it's increasing. Okay? When the slope is negative, it's decreasing. Okay? Ta-da! The first derivative test. Okay? We talked just slightly about that yesterday. Okay? So, we're going to go ahead and just steal a function from the book. So we know it'll go great. So, here's what we've got. F of x is equal to x to the third minus 12x minus 5. Okay? And what I want to do is I want to find all the intervals of increase and decrease. And I'm also going to go ahead and find maximums and minimums when we get to that point. Okay? So, I want to find intervals of increase and decrease, okay? And then I want to find local max and min. First of all, we know what this function is going to look like. It's a cubic. That's not a mystery to us. You've worked on it in Algebra 2. You worked on it in pre-calculus. Okay, and I think we've even hit it here a little bit too. Okay, so what do I got to find? I got to find my derivative so I can find my what points? Critical points. So if I go f prime of x is equal to 3x squared minus 12. Okay, so I'm going to, so my critical points, what do I got to keep doing to find my critical points? Equal to 0. So 0 is equal to 3x squared minus 12. I'm finding my critical points. There's no points that are undefined here, so 3x squared minus 12. 12 equals 3x squared. X squared equals 4. X equals plus or minus 2. Those are my two critical points. Okay? So then we can do what we talked about briefly yesterday. Okay? Is we can just make a graph of my slopes. A line of my slopes. -2, +2. Okay? Why did I plot those? Because here, my slope is 0. Here, my slope is 0. Okay? So now I've got to find out in each interval, is my slope positive or negative? Okay? How would we do that? Well, we can just go ahead and plug in values. Okay? So let's go ahead and plug in like 4. We don't even have to plug the whole thing in. We've just got to decide, is it going to be positive or negative? If I plug in something like 4 into my derivative, it'll be positive. So in this whole section, my derivative is positive. How do I know that? This is very important. My derivative is a continuous function. So there's no jumps, there's no gaps. If it was positive here, it can't magically turn negative unless there was a 0 point. Okay? So now if I go over here, honestly, if I think you apply some good logic here, you can tell it's going to turn negative. Okay? There's a reason why, because this, if I would go back here and 3x squared minus 4, 3x minus 2x plus 2. I don't know how much we've talked about this. We'll have in another class. This is a single root. So there's going to be a sign change there. It's going to change from positive to negative, or negative to positive. Anyway, so this is going to be negative through here. I could tell that by plugging in 0. I'm going to get negative 12. This is just for my slopes. And then here, I've got, this is going to be positive. I could plug in negative 4. So what can we decide here? Well, we want the intervals of increase and the intervals of decrease. Okay? So from negative infinity to negative 2, what is my function doing? You know what? They use a soft bracket here. Okay? Is it increasing or decreasing? Increasing. Okay? And then from negative 2 to 2, it is decreasing. Okay? And from 2 to infinity, it is back to increasing. Okay? So there's my intervals. Okay? Okay. Let's take a look at this, because we haven't decided whether it's a maximum or minimum yet at those critical points. First derivative test for a local extrema. Suppose C is a critical point in continuous function f, and then f is differentiable at every point in the interval. Moving across from left to right, if f prime, so f prime is which is the slope, okay? Change from negative to positive, then then f has a what? It has a minimum. Okay? If it changes from positive to negative, it has a maximum. Okay? And I think that should make sense. Because you've got your hills and valleys and all this good stuff. Okay? Number 3 is kind of important. It says if f does not change signs at C, that is, f prime is positive on both sides of C, or f prime is negative on both sides, then f has no local extrema at C. How could my slope be positive on both sides? Yeah, it kind of comes up, it's flat, and then it goes up again, like a cubic. Okay? So right here, we can see from the slopes, using the results of the first derivative test, it has a local max at x equals what? -2. Because it goes uphill, and then downhill. It's got a local minimum at 2 because it was going downhill. Now it's going uphill. There we go. And if we wanted to find what those maxes are, we just plug them in. I'm not going to waste your time doing that. Okay? So that gives you enough to do your homework successfully. So I better fix that. I think we were all in a better place today, weren't we?
Yeah.
Isn't that weird? Do you guys know who Jordan Peterson is?
No.
He's a psychologist that has kind of been in the news a lot. He was kind of the voice of common sense a little bit before. I shouldn't say common sense because I know. The voice of, I don't know. Anyway, he, about 2 years ago, it kind of came into prominence. And he was talking about one of the main roles of a teacher is to motivate and bring this stuff alive. Otherwise, just read a book. I'm like, okay, well, I need to do a better job with that. Excuse me. What was I going to do?